What's up, everyone? So last week I got a comment from one of the viewers who asked me to try to do a video about inequalities with modulus. In other words, trying to do inequalities with absolute values. So today we're going to take a look at the examples here. Here we go. Alright, so here is the first problem. Let's start from the easy one. We have the absolute value of x squared minus 5x minus 24 is strictly less than 2x plus 20. So how should we do it? Well, the first step is, since we have the absolute value, let's take it out. If we take out the absolute value, we now get the following. The expression on the left hand side, x squared minus 5x minus 24, is now bounded between 2x plus 20 and negative version of 2x plus 20, which suppose that, of course, 2x plus 20 is some positive value. Then in this case, we will get two inequalities, and we're going to solve each one individually. So on the left hand side, we get negative of 2x plus 20 is straightly less than x squared minus 5x minus 24, which if we simplify it, we get x is straightly less than 1, or x is greater than 4. Good. So we get x squared minus 5x minus 24 is straightly less than 2x plus 20. And if we simplify it, we get x is bounded between negative 4 to positive 11. Great. So if we look at these two conditions here, we have negative 4 is straightly less than x, straightly less than negative 1. Or you can put a comma here. 4 is straightly less than x, straightly less than 11. Now we are going to jump into the second inequality. Alright, so now we're moving on to the second inequality. This time we have absolute value inside of another absolute value. Namely, we have absolute value of the quantity, 2 absolute value x minus 3 plus 7 is greater than or equal to 9. How should we do it when there are two absolute values and one is inside of another? Well, first, notice that on the left hand side, the absolute value is actually the oldest thing, meaning that's the first thing we need to take care of. So, using the definition, if we take away the absolute value and leaving everything inside, we get 2 times the absolute value x minus 3 plus 7 is either still greater than or equal to 9 or straightly less or less than or equal to negative 9. Again, why? Because of the definition of absolute value. If we consider the number line again, we will be able to see that if we call everything inside is just some variable y, and we have absolute value of y is greater than or equal to some positive number, it means that y itself has to be either greater than or equal to that positive number or less than or equal to the negative version of that number. Okay, so this is not the formal way to write it. Of course, we're supposed to write the left hand side in the inequality, but we're going to split into two cases anyway. So we have 2 times absolute value of x minus 3 plus 7 is greater than or equal to 9. We get x is less than or equal to positive 2, or x is greater than or equal to positive 4. Now remember, this comma right here is just saying the word or for the situation. So we finished the first case already. Let's jump into the second case. But notice, by the definition of absolute value, the left-hand side has to be non-negative, meaning that the minimum of the left-hand side is 0. And we know that we cannot have 0 being less than or equal to -8. So for the second case, we actually get no solution. Therefore, if we combine both cases together, we get the solution will be x is less than or equal to 2 or x is greater than or equal to 4. Let's move on to the third one. Alright, so here is our third example. We have the absolute value of the product x times absolute value of x is less than or equal to 100. How is it different from the last example? Well, in the last example, we also had absolute value inside of another absolute value, and we also have something times the absolute value. However, in the last example, we had some constant multiplying with absolute value, but this time we have a variable multiply with absolute value of some variables. So let's see what has changed and how we are going to solve this kind of problem now. First, we can consider two cases. If x is greater than 0, then of course we see that x times absolute value of x is equal to x times x itself, which is x squared. Now, what if x is less than 0? Let's see. X is less than 0 provides us x times absolute value of x is equal to x times, well, since x is less than 0, absolute value of x is going to be negative of x itself. So we get x times negative of x, which is negative x squared. Next, positive value. Well, don't forget to also have absolute value right outside. So if we take the absolute value of the end result, we get absolute value of the products, which is x squared, is going to be plus x squared. Where the other equation, we have absolute value of products, which is absolute value of negative x squared, is going to be plus x squared. Again, since x is a real number here, we spare x, we always get something non-negative. We 0, we positive. And therefore, it doesn't even matter whether x is positive or negative. The left-hand side is going to provide us x squared. So we now get the left-hand side, which is x squared, is less than or equal to 100. So now you can either factor out or just take the square roots, and don't forget you need to keep the signs. So we will just simply ending up with x is between -10 and +10. That's it. So this is a very special situation that we can somehow manipulate everything inside of the big absolute value, and we can just simplify the products into something very clean and nice so that we can just solve it quickly. In the next example, we will see what happens if it's not something that's easily simplified, and we'll figure out how we can solve such an inequality with absolute signs. So I'll end up today's video at here. For the last two examples, I will show it in the next video. See you next time.